We moved out here a few months ago, about 4 months ago. We are starting to host meetups. Last month we had the first MySQL meetup at Lithium, which was by Box about OpenTSDB, and today we're going to have Ryan talk about MySQL 5.6 on Amazon. We have a few things to raffle. We have a few books and a couple of vouchers. We want to thank our sponsors, which are Lithium for hosting us, providing beer, Percona for helping us out, providing the pizza, providing speakers, and O'Reilly for providing books. And Aaron is helping me out with what to remember to say. What else, Aaron? And Mashery for sponsoring the tech equipment to tape this event. We do not yet have a session for next month, but MySQL Connect is over this weekend, and me and Aaron are going to try to hunt somebody down to do the next session. Without further ado, Ryan, MySQL 5.6 on Amazon RDS.
Don't forget to turn off your cell phones.
I think we usually start with, is anybody hiring or does anybody want a job?
Anybody looking to be hired? Yeah, let's start there because I think everybody else is hiring.
Yeah.
I'm going to start with that. We're hiring a senior DBA ourselves. So, anybody else?
Rocket
Wants to
Lawyer's
get
looking
hired
for a
or-
junior.
Looking for a junior?
Yeah. Rocket Lawyer.
Rocket Lawyer looking for a junior DBA?
Twilio is looking for several MySQL DBAs.
Several.
I don't work at Twilio, they're a customer. They asked me to do that, Peter, don't look at me like that.
Anybody else looking for a job or have a post? James.
All right, tell everybody, are you looking for a job?
Yes, but I'm more of a senior software engineer. I've been working 10 years in the field, mostly on lab technologies, and I have won some awards. I've been seeing them from my work. But I'm not really a DBA expert. I know how to design databases, but I still feel I have a lot to learn.
All right, so if you're looking for a systems guy, hit him up after.
We have more than just DBAs. Our meetups towards DBAs and developers and backend.
Yeah, some of us are developers.
That's true.
We're the money won't be.
All good?
Yep.
All right, so my name's Ryan Lowe. I'm here to talk today about running MySQL 5.6 on Amazon RDS. I'm a consultant at Percona, so we have a lot of customers on RDS and a lot of customers who are thinking about or asking about moving to RDS. It's actually a very large topic, something that we can't really hope to cover in 1 hour. So I'll go for sort of breadth over depth in a lot of places. But if at the end you think I missed anything or you have any questions, just ask me and maybe I'll write a follow-up blog post or interrupt me at any time during the presentation and I'll do my best to answer your questions. A logistical request for you is next time, podium. So I have like no idea what to do with my hands, and my presenter notes are across the room. So we'll start with an introduction, a very high-level overview of what RDS is, and then we'll move to the RDS Web UI settings and more advanced features. Don't worry if you know everything in the introduction section. It's mainly to get us all on the same page. So really quick, how many people here use Amazon Web Services in any form? Lots, good. What about RDS specifically? And how many of you love RDS? Just one, two? I got a yes earlier. Whenever I ask that question, I usually get 0 yes. You like it but don't love it?
Yeah.
Okay. This is the first group I've ever seen that anybody said, yes, I like it or yes, I love it. Most people are just plagued with issues when running it. So we're going to end the talk today with some tips and tricks and some gotchas and things that you need to know that will make you more likely to like it because you'll know what not to do in RDS. Let's see. So Amazon has over 24 web services available, and although we're only going to be talking about RDS today, I think it's really important that even though we're all mostly DBAs with some developers and some server folks, that we all know, at least at a very high level, what each of these services do and how they can help us. Oftentimes, like you may find yourself using MySQL as a queuing system, which it's not designed for and you shouldn't do. And using it in that manner is actually going to hurt you a lot more when you're running on RDS than it would if you're just on bare metal hardware. So Amazon has a simple queuing service that if you are using your database as a queue, you should migrate off to that. And the same goes for if you find yourself querying the same small, relatively static set of data, you should use Elasticache just like you would Memcached in the real world. So take a couple hours if you haven't already and really familiarize yourself with all their new offerings because a lot of stuff can and should be taken out of MySQL and put in a more appropriate dedicated service. So the focus of this talk is about RDS with MySQL 5.6. So I just want to give an overview of sort of what you get by just upgrading to 5.6 over 5.5. First, there are a number of very cool optimizer improvements, the most prevalent being index condition pushdown, multi-range read, and file sort optimization. Index condition pushdown can move a lot of the processing of the where clause to the storage engine. So instead of fetching entire rows and evaluating them in the where clause, the storage engine can prune the result set by examining index tuples, which is really nice. The result is, of course, less I/O overhead for the base table, and then less internal communication between the server and the storage engine. With multi-range read, instead of retrieving the full rows using a sequence of small out-of-order reads, multi-range read scans the index ranges in a query, then reads all those disk blocks using larger sequential I/O operations. And this speeds up things like UCA joins, like think InnoDB foreign keys. And this really only benefits those of us who are not using SSDs. And finally, the file sort optimization I mentioned, it's for queries that combine order by non-indexed columns and limit clauses. And one of the big improvements in InnoDB is the availability of persistent optimizer statistics, which can provide improved accuracy over restarts and increased consistency. There are also a lot of concurrency improvements, which are the result of a split kernel mutex, multi-threaded purge, separate flush thread, and the ability to prune InnoDB table cache. Then there are a lot of information schema enhancements with a lot of InnoDB metrics that are newly available. Let's see, what else? The replication improvements, NoSQL via Memcached, right? We finally have an official NoSQL interface to MySQL. We had one for years with Handler Socket, and I did a lot of benchmarking and a lot of presentations with Handler Socket, but it never really caught on, and I thought it would. And I guess one of the major reasons might be that it wasn't included by default, wasn't easy to set up, this, that, and the other, but now it's included by default. So we'll see over the next couple of years on how popular the NoSQL interface gets. Let's see. The replication improvements in 5.6 are fairly well known. A lot of customers actually look to these as the most compelling reasons to upgrade to 5.6, including row-based replication optimizations, multi-threaded slaves, replication checksumming, remote bin log access, and things like that. So 5.6 replication is a very deep topic by itself. A lot of blog posts, a lot of webinars on it. You should go look it up and just use those for reference. And finally, there are many instrumentation improvements and diagnostic improvements via the performance schema. Peter actually did a webinar on this a while back on the performance schema improvements in 5.6. It's well worth an hour of your time, but my 10-second overview of the performance schema is it can be very, very expensive to enable, but it's certainly interesting and worthwhile to do in a non-production environment so you can see what's going on in the server. Peter, you agree? A lot less is still a lot, says me. So the previous slide was 5.6 enhancements that I think are the most interesting. And Amazon actually published a blog post about what they find to be the most impressive features. And although there's certainly some overlap, it's really interesting to derive what their customers must have been complaining the most about because of the order in which they precedent. So first is crash-safe read replicas. I have to assume that replicas crashing were a significant issue for their customers. And then InnoDB integration with Memcached and binary log access came third on the list. And this is actually a really, really cool feature in 5.6 that wasn't available before. And I think it's really interesting because savvy DBAs can perform a lot of tricks and stream them to other servers remotely to get real point-in-time recovery if you know what you're doing with the binary logs. Next is online schema changes, and this is a pet peeve of mine. 5.6 offers more online schema changes than 5.5, but not all alter operations are online, right? So Online schema changes, your mileage may vary. Just be sure to understand what exactly your alter is going to do. Because MySQL, in this respect, is not up to par with other relational database management systems. And finally, they mention the ability to have full text indexes in InnoDB. And I suppose this is a really important improvement because they were previously only available in MyISAM. But again, if you find yourself using InnoDB or MyISAM full text indexes, you should really evaluate a third-party dedicated full search text product like Sphinx, Lucene, or Solr, or Amazon even has a search product that you can use. And if you're all Amazon, then you should probably go with that. A coworker of mine did a series of blog posts about MyISAM versus InnoDB full text searching, and you should go take a look because the results will surprise you. The exact same data and same queries often return different result sets. So there may be some unexpected changes. That's the end of the overview section. The next section is a walk through the RDS dashboard. I'll basically go through the process of provisioning a new instance. And there's a lot of screenshots here, but I'll try to do deep dives where I think things are actually really interesting. So when you first log into RDS, you get, this is a screenshot of the left-hand nav. From top to bottom, the database, this is where you can provision a new database or look at the details for an already provisioned database. And instances, it's just what it says. It's a list of your running instances. And this is really only useful if you have less than a couple dozen running instances. If you have more than that, you really need to familiarize yourself with the command line tools because that's really the only good way to get metadata about your instances. Next are reserve purchases. And I'm not going to talk about that at all today, except in this little piece here. So I'll give you a quick overview. They allow you to pay in advance for instances. So you pay a one-time fee, and then you get a reduced hourly usage fee. And there are three ways to reserve instances: light, medium, and heavy utilization. So with light utilization, it's basically if you have an instance running for maybe 7 to 12 hours at a time, so testing environments, things like that, or short-term projects, that's a way that can save you about 50 to 60% on a 1 or 3 year basis. For medium instances, things that you're running for maybe most of the year, 10 months, 9 months, but do have some variability. You have a higher upfront payment, but a lower hourly cost. And then heavy. Heavy is if you listen to anything about the reserve purchases, the heavy utilization are interesting because that's for production steady state workloads. So if you know that you have a production box that you want to be up 100% of the time for the year, you can just have a more significant upfront payment and then the lowest hourly cost. And if you make a 3-year commitment, they say you can save something like 73% over the standard cost. So there are ways to save money in Amazon, despite what a lot of people say. So next is a snapshot dashboard. And this is where you can view and manage the manually or programmatically taken snapshots, create, restore, copy, delete, things like that. And then security groups, parameter groups, option groups, I'll talk about those in detail later. Subnet groups, I won't, I'll just touch on them here. It's a specific collection of subnets that you create specifically for your RDS instances. It allows you to specify a particular virtual private cloud, and it just makes automation a little bit easier if you're going to try to automatically spin up new instances. Next is events, and event subscriptions. That's where all of your notifications go for security group changes, parameter changes, option changes, or CloudWatch changes. And you can subscribe to any or all of those. So that's a sort of a neat feature. So your first choice when you're spinning up a new RDS instance is your database engine selection. And I think it's really interesting to note that there are 3 options for Oracle, 4 for SQL Server, but only 1 for MySQL. And I don't know why this is. I don't know if it's a licensing issue or what. But do note that it is the MySQL Community Edition. So you don't get any of the features with the Enterprise Edition, like thread pool or authentication for Windows or PAM.
You can't do clustering or NDB clustering, even though that technically is free.
NDB, no, you cannot. Peter, why isn't it Percona? Yeah, I don't know. Well, I'll bring it up with Amazon in my next meeting. No, yeah, I don't know. Maybe someday. So the second choice I think is absolutely perfect, and I love this. A lot of people think that it's typical Amazon upsell, but I really like to view this as this is our reference HA architecture, and we suggest that you use it in production. So we'll talk about multi-AZ deployments and provisioned IOPS later. So it's important to note that their production HA offers 99.95% monthly uptime SLA. So what is that? That's 21.5 minutes of potential downtime per month. And a lot of you are smiling, you probably have better uptime on your laptops. And for some people, that might be a deal breaker, right? And for some people, that might not be too bad. It might not matter. But of course, there's always more. There's a mandatory 30-minute maintenance window. So each week, you can potentially go down for an additional 30 minutes. And this is where they do system upgrades. This is where they do the minor version upgrades or network maintenance and things like that. So in reality, Amazon actually offers 99.65% uptime. So always do the math yourself, always read the fine print. And even this number is really subject to, well, it depends on what region you're in. It depends on what services you're using, this, that, and the other. So you know, don't buy into the marketing. So this is the first. So the 30-minute weekly downtime, and I'll talk a little bit about this later, is for all the system maintenance. And what happens if you're in a multi-AZ deployment, you have your active master and a passive master. So they do all of the maintenance in the passive zone first, and then once that comes back up or once it's available, then they do a failover, and the failover takes about 3 to 6 minutes. So you're theoretically limiting your downtime to about 5 minutes a week, right? But that's only if everything goes well. And they also don't change the guarantee if you sign up for a multi-AZ deployment, right? So while you're probably going to save if you're in a multi-AZ deployment, there's no guarantee. They still say it's 30 minutes. Does that answer your question? Yeah. All right.
But you can also control that further by not auto-upgrading.
Yes, and we'll talk about that in a little bit. But auto minor version upgrade is an option, and that's you know, whether there's no right or wrong answer whether you choose to do that or not. It's really how tolerant you are to risk or what environment you're in. If you're still in a development environment, there's really no harm in auto minor version upgrades. It'll keep, no, you disagree? Yes? No. Oh, okay. Yeah, so it can be a good thing or a bad thing. You can control those things, but even if you don't do auto minor version upgrades, the SLA doesn't change, right? You still have that potential 30-minute outage. So your mileage may vary. This is the first main screen where we're actually provisioning an RDS instance. We've specified MySQL, and the next drop-down is a license model, right? And I was actually really excited when I first saw this. I was like, oh, let's choose the, oh, they only show GPL, right? And I think this is just to let customers know that this is actually GPL, because a lot of customers say, well, we don't work with GPL software because we misunderstand it. Obviously, people in this room don't have that problem, but others do. The next is you can choose the database engine version. 5.6.12 is the most recent and only version that they have for 5.6. You can also choose 5.1 or 5.5, and they've got not every version there, but a lot of them, enough of them. And most of this talk is actually somewhat version agnostic, but 5.6 is the focus. Next, we choose the DB Instance Class, and it's really important. Whoops. That we know the differences between each of one of these versions, because they can affect pricing, availability, as well as your subsequent options when you're configuring your instance. And I think that these are the micro, small, medium, large, blah, blah, blah. Those are the same for regular EC2 instances, not just RDS instances. So I talked a little bit about instance pricing earlier with reserved instances, but this is the official on-demand list for US East Northern Virginia region. And pricing does vary between region. So these prices per hour actually look really compelling, right? 5 cents an hour. It's important to know what these translate to on an annual basis. So it ranges from less than $500 to more than $33,000 a year. And just for funsies, I threw in the price of a Dell R910 with a half a terabyte of RAM. It's $19,000, so just over half of what running a high memory quadruple XL instance will run you for a year. So it's not an apples to apples comparison, but you know, you certainly should do the math and see if running on the cloud will actually save you money versus just running on bare metal hardware.
Are those pricing for reserved?
No, this is standard on-demand pricing for US North Virginia. So with reserved instances, we can expect a 1-year commitment to basically cut these numbers in half. So for the quadruple extra large, you're talking $16,500. But if you do a 3-year commitment, then you can save, I think it's 73%. So whatever 73% of 33,000 is. So you can save a lot of money. The other ways that people like to save money in other AWS offerings are to use spot instances, which are something that, okay, this is the price I want to pay. If there's available, like, let's make it happen. But that's not offered for RDS, right? You either have on-demand instances or you have reserved instances. Yeah, so just keep in mind at the end of the month, your costs may be significantly more than you anticipated. Actually, I did a presentation a couple of years ago when they first introduced provisioned IOPS, and this was in New York at a Percona Live event, and I didn't keep track of my costs, and the presentation ended up costing me about $2,000 in benchmarks. So just be really, really careful when you do that. So here's a screenshot of the capabilities of each instance class. They're all 64-bit anymore. The only differences, of course, are the processor, memory, and I/O. And if you don't know already, Amazon doesn't give you CPUs. They give you something called compute units, which are basically equivalent to a 1.0 or 1.2 Opteron 2007 processor. And of course, they do this because there are many classes of hardware and CPU underneath that are powering your instances, and this is really the only way to get equality. So in reality, we often, with databases, want faster CPUs rather than more of them, because especially with MySQL, not everything is easily parallelized among multiple CPUs. Like an individual query execution is single-threaded, so it will benefit more from a single faster CPU than more CPUs. Looking at memory, only the high memory double XL and quadruple XL really look like they're database class machines to me. It's very rare anymore that somebody shows me a database server that has any less than 32 gigs of RAM. I mean, let's be honest, I'm pretty sure the Percona corporate blog has better specs than any of these, right? So just be wary what you get.
Right, and don't they have more memory those days, or is it only for instances?
These are the ones as of last week for the RDS.
So they don't do the cluster.
Not for RDS, yeah. Someday, maybe. And there are a couple of factors why they might be limited at what is it, 68 gigs of memory, right? So the first is a lot of people just use RDS in the staging and testing environment or for functional testing, so small instances don't really matter. Or Amazon has a general philosophy of scale out rather than scale up, so they may be sort of forcing your hand to choose sharding and partitioning rather than trying to encourage their users to scale up with larger instances. And the third reason, and probably the most correct reason, is that their infrastructure simply can't handle single instances larger than this, or at least not enough to provision. So maybe they're waiting for an instance or an infrastructure upgrade before they start offering something with 128 gigs or 256 gigs of RAM. Of course, it's all sort of speculation. I'm just going to go real quick through the instance classes. Micro instance with less than or 630 megs of RAM. It's not useful, not even for testing. Small, same thing, not useful. I never use it. I'm getting quizzical looks. Maybe some people do use micro and small, but I've never found them useful.
I need a database of my mom's cats.
Depends on how many cats she has, right?
And that's how it starts.
Yeah.
It's all the plants and the neighbor's plants and the rest of it.
Next thing you know, it's a full-fledged CRM engine. And then, no. So generally speaking, I avoid micro and small instances. There's some sort of free micro instances that you can get for some period of time to test. But in my mind, the hassle isn't worth it. I'd rather pay for a medium instance. And a medium instance is actually my go-to instance for functional testing, proof of concept stuff. It's got 4 gigs of memory, so it's certainly not anything that we're going to run production off of. But it's if I need to just spin up a quick Rails app or do some functional testing in MySQL across versions, that's the way I do it. Large instances are where we really start getting into machines that are at least viable for production work. 8 gigs of RAM, 4 ECUs. It's not going to do a lot of production work, but if you have a service-oriented architecture and you have some service that's really small and database-backed, that doesn't get a lot of traffic, this can be a perfect thing because you've got built-in high availability solutions, and it can excel at that kind of workload. The extra large, with 15 gigs of RAM, 4 cores, it's fine, again, for low to moderate workloads. I actually like this instance because it's optimized for provision to IOPS, and it's got 1,000 Mbps. So I'll talk more about provision to IOPS actually in a couple minutes. Don't want to get ahead of myself. High memory extra large, it's not particularly useful for me because it's not optimized for provision to IOPS. And without provision to IOPS, RDS it's again, much less useful. Because of the limited memory, we know that we're going to be searching from disk quite often. And if you don't have an optimized I/O subsystem,
What about in the case of ephemerals, which they are both in?
so I actually have a customer, one customer, and this is, I've only seen it once, that didn't want to pay for provisioned IOPS. So they spent all their money engineering a very robust, for their workload, HA solution. So they use all ephemeral storage, and they don't care about the persistence of their data. And that's a really interesting and slightly dangerous way to go about it, but it works for them, right? So they've got HA proxy running on every single host in a very complex set of rules, and it works for them. They have instance failures all the time. Ephemeral storage is just that. It's ephemeral. So
Well, it's just I've noticed that IOPS has generally been can be very unpredictable if you don't know what your developers are doing. And I was wondering if there is some kind of interface to say if my cost for an IOPS backed M2XL hits $1,000 to stop everything.
you can write that functionality with the command line tools and the API. It's incredibly easy to do. Yeah, it's also incredibly easy to run up your bill really fast, and we'll talk about it a little bit later. But once you provision IOPS or to a system, you can't provision less. Like I can't go from 20,000 IOPS to 10,000 IOPS. I just have to provision a new instance. But I can go from 10 to 20,000 IOPS, right? So I can go up but not down. So it's really easy to get that monetary creep up there. But there's a CloudWatch metric that you can watch to see if how you're utilizing your IOPS, and if you're getting your money's worth, I guess. But you can't, it's pretty easy to say, oh, this is what I've done, kill it, right? But no, there's no way in the web interface that I'm aware of.
There's one, I remember running into, there's one gotcha with Amazon that they haven't set up for it yet. If you get past 10,000 provisioned IOPS, they will put a hard stop on it unless you call their customer support, but they don't have any indicator that says you hit the 10,000 IOPS limit. So it's like, it's really kind of creepy that like a lot of times you want to have a lot of IOPS, but there's like a 10,000 IOPS limit unless you call customer support.
That's interesting.
Right now.
I don't know that that's universal because when we benchmarked, or when I benchmarked for this and the other things, we got to 10,000, 20,000, then we looked at 30,000 as well. And I didn't have to call them, but.
It might be based on how many instances you already have running or something like that.
Yeah, or your account length, right? So Amazon, I'm sure, has some very intricate infrastructure to sort of try to detect fraud and things like that. Did you get it resolved?
Yeah.
Okay.
Totally resolved, but it was like annoying.
I imagine very much. So yeah, there are all sorts of little quirks surrounding it, and you'll find more the more you work with them. So double XL, I really like this. And then quadruple XL. This is actually my favorite because it's the biggest and most expensive. Is that me? And most of my customers actually end up migrating to this no matter what size they start on. And the reason they do this is because it's much cheaper to give Amazon money than to invest in engineering effort to design a proper sharding strategy. So most people end up here. Am I wrong? No. Yeah. So just be careful because it's a very slippery slope, and you get down that path, and all of a sudden you're paying for 30,000 provisioned IOPS a year on a quadruple XL instance. So back to the instance details. We've covered instance classes. The next option is whether you want to do a multi-availability zone deployment. And you'll recall from the first slide that this is the suggested HA architecture. It defaults to yes, but you can say no if you're doing testing or don't care about HA. But before we go into the details of what exactly a multi-AZ deployment is, you need to understand the concept of regions and availability zones. And I'll try to go through fast through this because I think most of you raised your hands when you said you've used this. So this is pretty basic stuff, but everybody needs to know. So it's, Amazon is hosted in multiple regions around the world, and each region is comprised of multiple availability zones, and the number of availability zones differs based on the region. Each region is designed to be separate physically, separate from a network perspective, and completely fault tolerant. And if one region goes down, it should never affect another region. And it provides these regions so that you can get geographical redundancy, or if your customers are mostly in Europe, you can spin up an instance in Europe to be closer to them or to meet regulatory requirements or just for HA. You should know that all communication within a region, among availability zones is not billed, but the region to region is billed at the standard internet rate, so on both the source and destination instances, so you get billed twice. Be really careful if you're doing multi-region replication topology because the costs can add up. Let's see. Yeah, so there are a lot of HA options. You can use elastic IP addresses to mask the failure of an instance in one zone and take over in another zone. And the best practice is to ensure that you have replication slaves distributed in each availability zone in the region. So in addition to a multi-AZ deployment, which gives you already availability zone redundancy, you can have multiple read slaves in each availability zone because it's, I wouldn't say common, but it's certainly not unheard of to have multiple availability zone failure within a region at the same time. So some other things about availability zones, they're not necessarily the same per account. So my US East 1A might be different from your US East 1A, and there's no way to reconcile what those are. So if you have an organization with multiple AWS accounts, you need to make sure that they don't interact with each other, those machines, because they may not be talking in the same availability zone, which will, of course, increase latency. And there's also no guarantee that each of us has the same number of availability zones in a target region, because if one zone fills up or gets close to being full, then new customers don't get to see that. So I might have 6 zones in US East, and Aaron might have 5, right? So it's pretty straightforward with some caveats. If you have an account rep and you call them, they will give you the DL, I'm told. I've never actually called Amazon representative.
Shake your fist when you call 8 words back.
Okay, shake your fist. You heard it here, folks. Tell them you're going with the Google database solution, right? Yeah, so there are 7 regions divided among North America, South America, APAC, and Europe. And use your judgment. Obviously, put your instances where your customers are. Just remember that pricing, availability, and performance all vary widely between regions, right? So think about it. The very first region that was built probably has a lot of older hardware than the very newest region that was built, depending on the refresh schedule of hardware that Amazon has, which of course is not public information. So when you provision a multi-database, sorry?
No, I thought it was just Virginia and California. I didn't know Oregon.
Yes, Oregon is relatively new.
Okay. So
Yeah.
I've never used this. So you can select which AK you want.
Yeah.
Okay, and your customer in this case would be where my application servers are going to be, I guess. So.
Yeah, so if you've got a large South American contingent, it might make sense for you to, spin up instances in Sao Paulo. Yeah. But most people tend to use Virginia and California and now Oregon just for geographical redundancy and creating remote replication slaves in either, just in case of an entire region failure.
Yeah, but RDS only specifically for MySQL.
Oh, no, I'm sorry. These regions exist for regular EC2 instances.
Yeah, but the RDS, when I'm selected, let's say my application is going to be on my server at work,
Mhm.
The application itself, the web application
Yeah, so you specify the region when you create either an RDS instance or a normal instance, and you just say it's the same one, right? So create them both in the same, like US East 1A. Yeah. So then they'll have faster latencies or lower latencies. So when you provision a multi-AZ deployment, Amazon will provision a primary instance and then synchronously replicate to a standby instance in a separate availability zone. It won't tell you which availability zone. It'll just create it automatically for you. And in case of an infrastructure failure, a hardware or compute unit failure, storage failure, it will automatically fail over to the standby instance. And then you actually don't need to do anything from an administrative perspective, right? Your application, if you've programmed it correctly, will just keep retrying, and bam, the instance is back up. It'll actually be the standby instance, but your application will be none the wiser. I took this instance, or this image from the AWS blog, and I think it does a great job at showing exactly what an multi-AZ deployment looks like. It is important to note that the replication here between primary and secondary is not MySQL replication. It's block level replication on the storage side, and then, for obvious consistency needs. So just be aware. In fact, the secondary doesn't even show up on your list of running instances, right? You see the primary and you see that it's multi-AZ. You cannot interact with the standby at any point unless it becomes the master.
What you said, you can no interact with that second one.
Hmm?
You don't interact with your application, you know.
Right, so basically you're paying for the primary, and the secondary exists as sort of a cold standby. You can't log into it, you can't do anything with it. It just exists as the receiver at block level.
Client application to the standby should not be there. The error.
So this only exists after a failover. So it normally does this path, but if this goes away, then this path will be exercised.
So my application needs to know where that's it.
No, it's the same endpoint. So as far as your application is concerned, oh, MySQL is not there, hold on. Is it there? No. 3 minutes later, it'll probably be there. And it will have moved. Yeah. Yeah.
So I have a question concerning, and I've not experienced this with RDS, but in Lowe, I always warm up my standby, warm up the cache, and I use a lot of other tools to do that. So what happens in RDS if you have a failover? You have a cold cache.
Yes.
do you not?
You fail over to a cold cache, which isn't an ideal situation, but you've also gotten rid of the high availability problem. So it's a trade-off, right? And maybe we'll get a persistent buffer pool so that you can just flush it, and then when you fail over, it'll be 5 minutes old or what have you in the future, but not now.
It's also worth noting that you pay double because you are paying for both instances.
Yes, and we'll get to that later. So if you have provisioned IOPS, for example, on a single AZ instance, you're paying what, 10 cents, depending on the region, 10 cents per IOPS month. So if you have a multi-AZ deployment, you're paying 20 cents. Same thing for storage, you're paying 12.5 cents per gig on a single AZ. If you have a multi-AZ deployment, you're paying 25 cents a gig. So yes, everything doubles. But the good news is you don't have to pay for data transfer to the secondary, I suppose. Somebody else?
Well, I was just going to ask whether this was actually available at all levels, even DB1 micro. I mean,
I've never thought of failing over a micro instance, so I don't know. That's a good question.
No, you can't do it with micros.
Okay. Yeah. If you're doing it with micros, you probably want to reevaluate your problem. Oh, yeah. That's a good question. I've never tried. Yeah, I've never tried, but Mike says no micros, maybe smalls?
I don't know about small, so I just don't know micros.
I know it works on large, because that's what I test with. The failover is Amazon magic that I won't speculate on. You're talking to a DNS endpoint, so whatever happens behind that. Yeah.
Since the replication is synchronous, what kind of latency does that?
Well, let's be sure replication is synchronous, right? Always use air quotes. Sorry?
What kind of latency does it add on what kind of performance impact does it have on the primary in terms of latency?
I haven't actually done those benchmarks, but I know that during a backup period, it can introduce, quite a bit in the tens of milliseconds latency for very brief periods of time. But that would be actually a really interesting benchmark. I should do that. All right. So there are a few advantages to multi-AZ deployments. Obviously, enhanced durability. It's synchronous replication from the primary to the standby. So all of your data, once it's been written and returned, is going to be in two places. You've got increased availability. On a single availability zone deployment, if something goes wrong, the storage goes away or the compute unit fails, then you have to initiate a point-in-time restoration. All right, and that can take several hours, right? Whereas with a multi-AZ deployment, that's going to take 3 to 6 minutes to do the failover. And the other problem with, of course, the single availability zone deployment is that you do that restoration and you lose all of the data after the last restorable backup. So you're theoretically not going to lose any data. It's also easy administration. Again, if you program your application correctly to try, back off, keep trying, then in a couple of minutes, it will seamlessly just appear to work again. Story time. So that's my...
I thought that was about replication.
No. So that's funny, I just got that. She's sick right now, so I haven't slept in like 9 days. So yeah. At Percona, we help customers like in a bunch of ways, right? We do the standard high availability stuff, performance audits, but a lot of times what people want to do is just use us as a sounding board for major decisions, major architectural decisions. And one of the things that we're doing a lot these days is, hey, should we move to the cloud? Should we move to RDS? So I recall a specific customer that we got on the phone. I had an 8-hour conference call one day. We talked about most of what's in this presentation, as well as most of the other Amazon services. And they specifically wanted to know about the reference architecture in RDS and any gotchas and things like that. So I told them, went their merry way. And fast forward a couple of months, they called me back about a separate application performance problem that wasn't related to RDS, but I hadn't talked to them in quite some time. So I asked, what HA strategy did you choose to use? And they said they went with the reference architecture, used multi-availability zones with read slaves in every zone in the region, and that the automatic failover happened far too often. They experienced data consistency issues and needless failovers in their mind. So they were very, very unhappy with Amazon's automatic failover. And I've heard anecdotal stories about this from my testing. And most of my customers, they don't really have a problem with the failover, especially data consistency issues. But your mileage may vary, so always benchmark, always test, especially failure scenarios. Back to the instance details page. Let's see. AutoMiner version upgrades, we talked a little bit about that before. It'll magically happen when 5.6.13 is available on RDS. One day you'll just wake up and it will have been done for you. But remember, that's downtime unless you configure it to not. So again, it's how tolerant your organization is to risk and to downtime. That's going to dictate that decision. Next is, the fun part, right? Provisioned IOPS and allocated storage. So for the allocated storage option that just asks how big you want your block device to be, obviously choose what you think you're going to need. You can undersize at this point when you're first provisioning because it's trivial to add storage later. But what I've found is that most of my customers are actually over-allocating storage because Amazon only allows an IOPS to gig ratio between 3 and 10. So if you want 1,000 IOPS, you have to have 100 gigs of space. And for those who like 10,000 IOPS, you have to have a terabyte of space, roughly. So most people over-provision on the size side of things anyway. Let's see. So provisioned IOPS, right? IOPS are, of course, I/O operations per second that the I/O subsystem can perform. And since disks are generally the slowest piece of any system, increasing the available IOPS, especially with these systems and their limited memory, can dramatically improve your performance. I think 9 out of 10 customers of mine are using the provisioned IOPS feature. So I imagine that most people who are doing this in production do as well. So although IOPS allocation seems relatively straightforward, there are some things you need to know. First, again, there's a hard limit of 30,000 IOPS that you can provision. for MySQL, but in truth, the theoretical maximum IOPS are a function of database I/O page size as well as available channel bandwidth. So InnoDB uses 16 KB. So on a DB instance with full duplex I/O channel of 1,000 megabits per second, the maximum IOPS for page I/O is going to be about 6,250 IOPS in each direction, right? So if you've got 50% reads, 50% writes, you can realize around 12,500 IOPS. It's important to note, though, that if one of the channels reaches capacity, the IOPS in the other channel in the other direction are not available. So if you're 90% reads, 10% writes, right, it's still divided 50-50, so you need to just provision more IOPS overall. Earlier in the presentation, we talked about instance classes, and some have network bandwidth of 500 megabits, some 1,000. Obviously, this will also affect the amount of IOPS that your RDS instance can realize, and it can be limited by the instance class. So I talked a little bit before about Amazon's CloudWatch metric. It's called a disk queue length. They say if you have, what is it? Let me see. 5 outstanding I/O operations per 1,000 provisioned IOPS, then you're using your IOPS well. So if you have 10,000 provisioned IOPS, you should have 50 outstanding I/O requests. So this next section is actually basically verbatim from the documentation. Using provisioned IOPS storage, increase the I/O requests the system was capable of handling, and then increased concurrency allows for decreased latency since I/O requests spend more time in the queue, and then decreased latency allows faster database commits, blah, blah, blah. So for example, some of this is a little counterintuitive. Consider a heavily loaded OLTP system provisioned with 10,000 IOPS that runs consistently at the channel limit of 100 Mbps for reads. If the workload isn't perfectly balanced, there's some unused write channel bandwidth. So technically, that instance would benefit from moving to 20,000 provisioned IOPS instead of 10, even though it wasn't fully utilizing the 10. And actually, increasing the provisioned IOPS can sometimes result in less utilized IOPS. So it's possible for the I/O consumption to decrease under these conditions. So if you see write requests decline, but an increase in write throughput, then your database is probably making better use of group commit. And so there are some edge cases there. But you should just keep an eye out on what your read channel bandwidth is, what your write channel is, and how many IOPS they're each using. Oops, sorry. So after that, yeah, the last database instance identifier, username, password, those are pretty self-explanatory. The additional configuration section, database name, port, those are self-explanatory. Choosing a VPC, we talked about that earlier. It just allows you to have more control over your network, your IP address ranges, creation of subnets, route tables, and network gateways. Next is you can choose your availability zone, and this is largely true, you can choose your availability zone, but if you select a multi-AZ deployment, you can't. And then option groups. And option groups are primarily for setting up and tuning the memcached interface to InnoDB, so we won't go into that there, but all the options are located there. Next, the parameter group. And this is where all the MySQL configuration variables get set. And one of the common complaints that I hear from RDS users or non-users in general is that RDS doesn't allow you the same flexibility as just running MySQL on bare metal or on an EC2 instance. And yes, that is absolutely true, but it's gotten better and better and better with every release, and Amazon has exposed more and more variables for you to configure. So I expect some parity in the relatively near future. MySQL provides 523 options, 35 of them NDB specific, so they don't really matter. And then Amazon RDS provides, 283, and 58 of them are immutable, things like base dir, data dir, things that you don't care because you're not managing the instance. So what's missing from the RDS configuration? Audit logs, memcached daemon, binary logs, relay logs, semi-sync replication, SSL, thread pool, and then a large block of other things that didn't fit into any neat category. So let's look at the relevance of these sort of individually. The audit log, right, that's an enterprise commercial plugin. So if you have MySQL Enterprise Edition, this is relevant, but since RDS only offers Community Edition, it doesn't really matter. Binary logs, It's enabled by default in RDS. You just lose the ability to use the old format, which you don't want to do anyway, or specify the base name or where it lives in the file system, or changing the max bin log size. And the flexibility of controlling the maximum binary log size is actually, it's not very common, but it is interesting for some workloads. And a coworker of mine said it best when he said, if you have the type of workload that would benefit from changing the max bin log size, you don't want to be on RDS anyway, so it doesn't matter.
What is the max?
What's the default value? I have no idea. In 5.6.
I think it's okay.
Is that the default in 5.6?
I think so.
Oh, sounds plausible.
Because I heard in RDS that it's, for 5.6, it's very small. That was one of the things that somebody said, he asked about, is it a 128 meg? It's something, they've heard there's some log that's set really low.
I don't know that that's it, but I can certainly check. Yeah.
I'll find out what exact variable it is.
Okay. Yeah.
Are these items things that are available off of both, or only off of MySQL 5.6, or what?
So these are the things that are missing from RDS tunables.
So main cache D, I think I saw in the beginning that actually support.
Yes, but it's not as part of the parameter group. It's part of the option group. So they moved it to a whole separate group, and I have no idea why, but yeah, you tune it over there rather than here, which is sort of counterintuitive.
So by saying variables are actually missing, meaning if you write triggers or store procedures, that you actually need to store a temporary value into memory, you can't do that? Or do you mean just
Oh, no, I just mean the variables, show variables. Sorry, I should clarify that. But yeah. So yeah, you can do all the normal stuff like that. The performance schema settings are missing, which is sort of a misnomer because you can actually turn it on and off via the web UI and then just turn it on and off via SQL as you would normally. They're just not in the parameter group, so it makes for an odd comparison between stock MySQL and RDS. Semi-sync replication is missing, which isn't all that surprising when you think about it because that's encouraging you to use a multi-AZ deployment, and they've got the synchronous replication there outside of MySQL. So I think that RDS would probably benefit from allowing you to have semi-synchronous replication, but I don't know. It's not on their list, I suppose.
When you say you don't have SSL, do you mean SSL for replication, or do you mean I can't even create an SSL?
SSL for connecting, and that includes replication and standard connections.
When you're talking about replication between, like, within a region server, but what about going across region servers? It's still block level, right? So there's no encryption on that block?
The primary to standby multi-AZ stuff, that's block level.
And is that encrypted at all? Do you
That is Amazon magic.
But if you're setting up RDS master and RDS slave, what kind of replication is going on from Amazon? I've got two contradictory replies. This was for 5.5.
You can set the bin log format.
Well, what?
You can set the binary log format.
So it will be MySQL that's the replication, it is not their own magic stuff.
They may have enhanced it, I don't know, but it's standard MySQL replication. I mean, you can show slave status, you can set it up just as you normally would if you so choose. You don't set up RDS, but you can set up from an EC2 instance. So yes, among master slave, it's standard MySQL replication. But I don't know about the block level encryption. I mean,
It's backed on EDS, right? So
presumably. Yeah. And I don't know how, if at all, having a VPC using SSL influences the block level stuff, but I know that a lot of security conscious companies want to use MySQL replication encrypted, but they will settle for using an encrypted network, right? So you can sort of get around the lack of SSL limitation by using, no, not all companies. Some companies, no companies.
not my
Okay. Some more liberal-minded companies would allow that. But I have to believe with all of Amazon's resources, this is something that's coming in the near future. I mean, this is not an amazing technical hurdle to overcome. SSL isn't anyway. Next is the thread pool. Again, that's a commercial extension, but both MariaDB and Percona Server have separate implementations of it, and that's something that Amazon may or may not choose to port into RDS in the near or far future. So the bottom line is Amazon still has a ways to go in terms of compatibility with the stock MySQL, but they're making more and more progress every release, with the obvious exception of things like InnoDB log file size, which still gets me to this day. Next is back to the configuration. Let's see.
So the default max bin log size is 134.217.728, but it has a range of 4,096 to
Somebody have a calculator? I don't know what that is. What's that? 128 megs.
So Karen was right. And this is 5.6?
This is the 5.6 default options.
All right. So the next is the security groups, and I talked about those a little bit. This is basically, instead of MySQL grants, this is what you use to control who does and who does not have access to the system. So if you've got a large set of applications or service-oriented architecture or things connecting from all over the place, it might be worth your time to invest a lot of time in your security groups so that there's no connectivity issues, which is a very common problem with people that don't understand the Amazon security groups. All right, so we've covered just about everything you need to know to sort of get up and running from a practical perspective. We're going to wrap up with just a couple of notes on tips and tricks and 5.6 specific stuff. And I think this is the number one question is external replication. So before MySQL 5.6 in RDS, you could not replicate from RDS to somewhere else. This changes in 5.6. So with 5.6, you can have an RDS master and a non-RDS slave. And this is really important for a lot of folks to do, ETL processes and things like that. It's just like setting up a standard replication slave. You just have to be aware to set your security groups properly so there's not a problem. However, you still cannot natively replicate from a non-RDS instance to RDS. And this is a big problem because a lot of my customers like to use the cloud as a magic DR site. And what they end up having to do is use MySQL on just a standard EC2 instance. You can technically do this if you use Tungsten or fake it by rolling your own with the bin log streaming, but just because you can does not mean you should, right? This is almost always a bad idea. I've seen this movie, it does not end well. So surprises and gotchas, there's a number of things that'll get you. There is no 5.5 to 5.6 upgrade path. In order to upgrade, you have to do a logical dump using MySQL dump or MyDumper or something like that out of 5.5 and then reload it into 5.6, which of course implies a lot of downtime. I know that this is on the path. They've publicly stated that they're working on it and they want to do it. So if you're a new user to RDS, just use 5.6 out of the gate. If you're an existing 5.5 user, if you're already in production, I would strongly suggest just waiting until you can do it via the click of a button on the web UI in 3 to 6 minutes, right? Otherwise, you're looking at potentially a lot of downtime. We talked about multi-availability zone support, but there is no built-in multi-region support. So if you want geographical redundancy, you have to do it within your application. And next, one of the promises of the cloud is that you can auto-provision based on load, so automatically scale and not have to worry about anything. Well, there's no auto-scaling support for RDS, and as I mentioned before, there's no spot instances. So I have to believe that Amazon is working on this. I have a number of customers who, they look at their CloudWatch metrics or they look at their Cacti metrics, and then they spin up programmatically another instance, but it can take a very long time, and it's not really an on-demand type of thing, right? It takes quite some time. So I hope this comes in the near future because that will make RDS a lot more compelling for me. Backups can be invasive, as I mentioned. Pricing also can be surprising. The monitoring capabilities are actually terrible, right? So you have CloudWatch metrics, but you only get a handful, right? You can't even pay for a good set of metrics on your RDS instances. So I always encourage everybody to use some sort of external graphing solution like Cacti or Graphite so that they can actually have visibility into what their RDS systems are doing. And then, performance, it's not always reliable. Right, the first write penalty, it still exists in RDS just like it exists in EC2. And some instances just seem to perform poorly or are flaky, and the only solution still is to provision a new instance.
Pricing can be surprising in which direction?
Never in the good direction. I've never had anybody come and say, oh my God, look how cheap Amazon is. All right, questions, comments, concerns? So if you get an instance, this applies to RDS as well as standard EC2 instance. If it's flaky or the ping times are extraordinarily high, kill it, provision a new one. That's what I do.
You can also stop it, restart it, and that'll provision it.
Stop it, restart it if you want to be less invasive. I'm more of a scorched earth kind of guy. So they were unhappy with the automatic failover, right? So what they did is they eliminated the multi-availability zone, and then they used standard MySQL replication among zones in the same region, and then just did their own high availability stuff. For performance, the actual call was application related, so we just fixed some code. Yeah, generally speaking, you're going to get very similar performance, assuming the MySQL configurations are the same on an EC2 instance, as well, side by side an RDS instance. They should be fairly similar. I mean, not particularly. No, it's pretty straightforward. It's basically a really, really nice interface on an EC2 instance with MySQL, right? So it's basically using the same infrastructure, just not presented in the same way. Oh, behind you, Aaron.
So if you're already running MySQL in an EC2 instance, what would be the advantages that you actually get?
So the major advantage of RDS is the automatic multi-availability zone failover, right? So for me, that's the most compelling reason. At that end, the triviality with which you can create a new slave. Those of us who have built slaves know that it's not rocket surgery, but it certainly takes time. Whereas if you want to build a new slave with RDS, you click build me a new slave, and you're done, right? So it's just ease of administration. If you don't have a DBA, RDS might be great for you. Or if you don't have a high availability solution, RDS might be great for you. Does that answer your question? Yeah. Yeah, absolutely. You kill the existing instance, but you do it much nicer. Yeah.
So I'm going to bring up somebody here. Somebody I work with, they are doing a proof of concept for a client to move to RDS 5.6.
Mm-hmm.
So they have an admin server and they want to dump from their data from 5.6 and move it over to somewhere else. And the 5.6 client on the EC2 instance hangs. You cannot do a dump from the 5.6 RDS. This works in 5.5. I've done it, so I know it works. They do too. They do it all the time. And they're having problems with dumping using MySQL dump.
Is it a bug in MySQL dump? Did you file a bug report?
They have.
Oh, psh.
So is anybody else experiencing or using MySQL dump with 5.6?
No. Extra backup. But yeah, I mean, the bugs that exist in 5.6 stock are going to exist in 5.6 RDS to a large extent.
How about the doc metrics? Those are alerts. They're only settable per instance. I don't know if there's a way to extrapolate that, like parameter groups, like across all your instances, or is it you have to configure the alerts per instance?
I actually don't know, and to be honest, I think they're not interesting enough that you should be using those. Like, I always like to set up external alerting as well as graphing and trending. I can certainly look into it and tweet you or something if you want to give me your email address. But I don't know because I don't find it that useful, right? It's just not something I use. All right, going once, going twice, going 3 times. Thank you very much, everybody. I think there's a raffle.